So I will continue with the talk, which is partly about ownership and modularization and in general, and partly how this context is approached by us at Shaper 3D. To understand this context, let me just quickly introduce the product we have, which is a multi-platform 3D CAD application, which runs natively on iPadOS, macOS, visionOS, and Windows. And it has a magnitude of different functionalities besides of parametric solid modeling, like 2D engineering drawings. It has 3 different rendering engines, one for modeling, one for visualization, and one for augmented reality. And it also syncs your designs across your devices. So I think this highlights pretty much all the complexity and the range of functionality it has. And besides of the product, I want to elaborate also to give more context about the evolution of our code base. It was started in 2013. It was basically a one-man show by István, our CEO. And of course, he committed to master. As time went on, the team grew. And even until 2017, when the team was like 10 people and 5 engineers, they were still committing to master, as you should do, right? But then there was a turning point. The code base was already around the 150K lines. And it was just not scalable anymore to accept the same understanding from all the team members, from all the details this code base has. So that's when PRs were introduced. Today, it's 1.2 million lines, 125 people. We roughly kept the ratio, so half of them are engineers and they're spread out in 10 teams. And for comparison, I've selected these 2 examples, which has roughly the same size as ours. Of course, these are different languages and so on, but so it's hard to compare. But I would say ours is better because it's smaller, right? Even because it's written in C++, which is quite a verbose one. So at this size, we hit another turning point, and we realized that it's the code base is so complex that similarly to when we switched to PR-based development, that the details cannot be understood even for long-time members. Just imagine that if there would be a new joiner, then you having to jump into an unstructured code base with this size, no joy, right? Then that's probably not something you would want to work with. So even though we were trying to, of course, write modular code, we realized that we need to be more deliberate about this. The disclaimer is that everything I'm going to share today is highly in progress, and I don't know when or even if we are going to finish it. But I think what's important here is that if we are able to introduce these approaches and then see some positive effects in our work, then we already achieved what we set out to do. So, problem. We have this part of code. I think it's very basic. So there is a view here, and this function is called at every vsync. And we introduce some kind of a system in our renderer, LOD, I don't know, it doesn't matter. Let's say it's, I don't know what is it, large object detector, okay? And then it has some distinct functionalities like selection, generation, and eviction. This looks reasonable if this is close to that CUF system. So you can control the different functionality separately. But as soon as the client is spread further apart, like this is what we have right now here on the example, a view and the renderer and some object in between. I don't know what it does. Then we have a problem. So this object, this quite distant object, has to be periodically poked to update this load system. But the shape part handler, or is it a load? I don't know. Then the order, of course, is also undefined. So without knowing the implementation details, probably I cannot tell which one should be called first. So I have to be careful about moving them together from here to there. And also the interface is probably quite unstable, because if I want to introduce some other subsystem in this renderer, then probably I have to change the client as well. So how did we fix it? First, we introduced the explicit notion of this subsystem, that there is this large object detector, and this eliminated the first two problems. But the interface is still quite unstable, because if we introduce something which requires periodical updates, then we have to change this code again. So to avoid this, we introduced the rendering engine as a high-level entry point for this module. And the contract is very simple. If you want anything from me to do, then just call this update function every frame, and I will take care of proper resource use and feature quality. And this is where we ended up with this. As said, this is a simple example, but I think understandable without knowing shapers really internal. So this evolution of our code base and the example also indicates that as the software system grows, so does the complexity, and then it becomes harder to understand, maintain, reason about. For example, if you have an issue with the build time, that's also caused by the complexity increase, because then you are just showing more files to the compiler. So that's why your build time also increases. So with modularization, we are trying to break the system into smaller self-contained units, and that basically brings us back to how the clarity and how the system was working and how we used it in the older times. When I'm saying system here, I refer to both the code base and the organization as well, because for scalability, you require to break these dependencies on both sides. So before going forward, let's first define what really is a module. I've made a mistake when starting this whole modularization journey, that modules weren't properly defined. So most of the teams formed their own representation. What we really mean here, is it a library? Is it what it is? I don't know. So if you want to start something like this as well, then you should come up with your own definition, what it really means for you. This was our initial definition, which is quite abstract here, but I think it grabs the main idea. If missed, the other important aspect is that these modules should be able to develop, test, and maintain separately. But this is still quite abstract, right? So is there something we can take an example from? We are two main languages we are using are C++ and C. So, and both use the module concept. So is there maybe something we can take from that? If you look at C++, C++ modules mainly fix the shortcomings of the headers. So it's more about encapsulation and that part. And the fifth modules, that's by definition, if you go to c.org, then it says that it's a unit of code distribution. Both of these are quite highly technical. And the module is not only about technical part. Yes, they define that there is some encapsulation going on, and also that that your module is probably defined on the code level, be it a package, a namespace, a directory, whatever. But our definition prioritizes more like the architecture aspects. That module is something which should have a distinct responsibility or responsibilities mapped to a certain domain. In our case, domains are like caching, or rendering, or the modeling itself, which are quite separate and have their own responsibilities. Also, a module is something which should be stable and stable abstraction, and which should have a high change resilience. So if something changes in the system, then you don't want your module to change as well. And this indicates that the technical aspect is more like an implementation one. So your module is more about the responsibility of the code and the ownership, and how it is built or linked, or whether it's a library or not. That's secondary important, but secondary implementation detail. You can have fine modular code even in a single library, or you can have a library for each module. It doesn't really change anything. Oops. Sorry. Okay. Oh, I'm. Thank you. Okay. So we have the modules. We decided what are the modules. We even made modules. Are we fine there? No. If there is no one who takes responsibility for these modules, then we fall back to the same situation where we came from. This indicates that there is an organizational aspect for modules as well. So you can define from the organization point of view as well what a module should be or what it is, like a unit of ownership, or that it defines the decision boundaries, like that every team or the owner itself is responsible for the roadmap and whatever has to happen with that module. And it's also a communication contract, because if you have a module that clearly communicates to the users, the consumers of the module, how it should work and how it should be used, and they should then don't have to rely on some internal knowledge. If you don't do this, they will rely on internal knowledge. I could have replaced module with owner in the previous definition, and everything would still apply. And this indicates that there is a feedback loop between ownership and modularization, because ownership pushes teams to modularize. That's how they can take responsibility of their own code, and it also makes ownership practical and sustainable. What's the kind of ownership did we introduce? This again, this is specific to us. It might be different for you. Our ownership model is based on modules, and which are owned by teams, and we expect any change, whether it's internal or external, to go through a code review. This helps to ensure quality and consistency, and this is a key principle for our modules. Of course, external contributions are allowed and welcomed, but that also has to go through the same code review request. Who reviews this code in this model? It's obviously the team, but does this mean that we fall back to the, I don't know, people-based ownership, that okay, this part can only be checked by this guy, this one, I don't know by who? No, what we are trying to do here is to introduce collective ownership inside the team. So we expect the team to share their knowledge inside the team, and everybody should have the same understanding where their code base is evolving and changing. Of course, that in practice that doesn't turn out to be that simple. Seniors have more knowledge and so on, but we try to encourage them by having small teams like 5, 6 people, and also the collaborative work is something we have in our processes. Sorry. Okay. So, how did we start? Anyone who is using CodeOwners file in its repository? You guys, I know. Okay, so not that many. So most of the well-known repository services like GitHub, GitLab, and Bitbucket has this functionality where you can have a specific special file where you can define individuals or team level ownership for the parts of your code base. And this comes with handy features like showing who owns a certain file, or letting you focus on the actual owned files in a PR. Maybe that's much bigger PR, and then you are not interested in all the little parts. And this was a key stepping stone in our journey. That's how we started. We started defining. We already started to think in modules, but the first step was to cover the whole code base, 100%, every file, dot files, and anything, and assign that to teams. And of course, this highlighted the good parts, some bad parts, and some parts which I don't even want to see. But at least we have an understanding about the whole code base. And we even introduced some mandatory checks, pull request checks, which maintain the level of ownership. It cannot decrease. So basically, anything you introduce has to be introduced with an explicit owner. Okay, so you became a code owner. Great. What do you do? Obviously, it's more than just writing code. We expect owners to maintain a roadmap about the module they own, because obviously they are the best and they have the most knowledge about their modules, how it behaves, where there might be performance bottlenecks, and so on. Also, the documentation. Yes, I know, self-documenting code, right? But that's not, that can't tell you why something is working the way it is working. It's more about the what. So we try to clearly document architectural principles in the code base, design decisions, explain the reason behind some complex changes in TR descriptions, and also try to document the public interface of our modules, because and not the way that this is a function which creates something, but again, the intention behind how it works and why it works that way. If you supply something to your clients, then that will be only consumed if you continuously keep updating them about the roadmap and how it looks like, your vision, how it can be used, how it should be used. So you have to spread that knowledge, and we are using, we have this Tech Talk series as well, which is a good forum for this. Code reviews, especially if there are external contributions, then it's very important to handle them in a timely manner, because if you don't, then you just undermine your credibility sooner or later, and no one will want to know because you won't say anything. Stability and innovation. This is about listening your customers, let's say customers, and how they use the system, and that there might be something that you haven't thought about, you are trying to protect it, but in reality, it turns out that that's not how it is used, and then in this case, some alternative ways might make your module more usable and loud. And in return, what you can expect is that you get to have an active involvement in these external contributions. An important point here is that this should be infrequent. If it's not, then that probably indicates that that these responsibilities, boundaries are not properly set, and then you just spend your time doing code reviews or whatnot. So where are we right now? So we have a common understanding about terminology, and also have an agreement about the goal where we want to reach. We started carving out smaller modules here and there, and also I think the discussions around modularization and the implications of this started becoming more frequent. Right now, all the teams mapped their responsibility areas. They found their modulars and revendors as well. And what happens now is that they are drawing up their own part of the map, and when this happens, then we will connect the word map and go from there. So basically, we are just at the beginning of this journey. But there are some practical steps as well. Like we do expect to reach a state when the reviews become mandatory. Right now, it's not mandatory for owners to approve a PR, because the way currently the code base is structured is, of course, suboptimal and would introduce just too many bottlenecks. Also, we have some thinking, some understanding where the code base is, but in practice, this might not map to the reality. It might happen that certain part of the code is changed always by some other people, or two modules change every time together. So we want to cross-check our assumptions based on history. And also, the plan is to utilize the code owners file for certain automated delegations, like flaky tests, errors, assertion validations, and so on. Finally, takeaways. Okay, code ownership is an enabler for modularization. It's not the only possible way, but it's a good one if you want to start this. It enables the system, again, the code and the organization, to scale together. You have to start at the right time. Maybe it's too early if you are small. Maybe it's too late. In both cases, there will be bottlenecks. I don't know if we started at the best time. We'll see. And these two reinforce each other, so you have to define them together, not like we did. And use tooling, either standard or custom, it doesn't matter. But to maintain ownership modularization, build from something small, like checking the code owners file, and from there you can scale up to more custom or more crazy verifications. And last but not least, you can start it anytime. You have to start small. We know that we are very far, but by staying disciplined and doing this iteratively, then it will have an effect. Maybe we will continue, not now. We'll see how it turns out. Thank you.